Now we're going to test our smart contract simply by using this command cargo test. You can see the test ran and it passed. So now we can continue. In order to deploy your smart contract to the Stellar network, the next step after testing your smart contract is to build your smart contract. And to do that, you use the following command: Stellar contract build. This is going to build your smart contract. The build is complete, and you can even see a hash that has been created, a WASM file and a WASM hash, and you can see it created a file target, under target release, another release. You're going to see the file WASM none, target WASM none. Yes, target WASM 9 none, release, and there we go. This is your WASM file that has been created. You can even further optimize your build by using the following command. Just hide this. Stellar contract optimize WASM target hello world WASM. So this is going to optimize the build, and it's going to create a new WASM file in the same location as the input. Let's do it. And yes, now we have an optimized version that is so it went from 575 byte to 538 byte, and the name of the WASM file is hello world.optimize.wasm. Now your WASM file is ready to be deployed onto the testnet, and this is what we're going to do next. First thing first, we need to generate a key pair. So a key pair is your address that has your private key and your public key, and that's what's going to be used to interact with your smart contract. So this is your wallet basically. To generate an address, we use this command stellar keys generate the name or the alias of your wallet address. And here we're dealing with the testnet. It's going to be on the testnet. We're going to fund it. And you see dash dash fund. So this is what's going to fund our wallet. Because remember, if it's not funded, then our wallet is not activated. So we need to fund our wallet. So I'll call it Alex. And yeah, so a new release. Okay, there's a new release that is available. So key save with alias Alex. So yeah, I've created an account, a wallet, and it's funded on a testnet. And we can also try to see our address using this command. So it's stellar keys address Alex. So it's gonna enables us to see Alex wallet address, and we have his wallet address here. And you can also see a list of all keys that you have generated. So the command is stellar keys ls, Stellar key ls. Okay, so we have all these keys that you've created. So now that you have that, we have our keys. We have we now want to deploy to a testnet. So we're going to use this specific wallet as the address that's going to interact with the smart contract, and we're also going to use it as the source account that's going to deploy that smart contract on the testnet. To deploy on the testnet, we use the following command: Stellar contract deploy, and our WASM target, make sure it's the correct name and the correct file, and the source account in this case is Alex. So I just have to change it to Alex. And the network we're going to be using is testnet, and the alias for this hello world WASM, we're gonna call it hello world. So that's going to be, hello world is going to be a representative of our our contract. So we don't have to write a whole long contract address hash for that. So this is our contract ID that has been generated, and its alias is hello world, as we name it here. So this will allow us to refer to this contract as its alias instead of contract ID. Now let's interact with the blockchain. For this, we're going to use the following command on the CLI. So Stellar contract invoke, and the ID of this is the ID of our contract. The source account is Alex, and we are in the testnet, and this is our function hello, and this is what we are passing inside the two variable, and we're passing James onto that in that function. So let me just copy this, and we're going to paste it here. And as we expected, it returned hello James. So there we go. We've deployed our smart contract in the testnet, and we also interacted with it. Let's try and see it in the test. Let's see it in the Stellar Explorer. So we in the Stellar Explorer, we're going to see our smart contract. So since we are in the testnet, make sure you're in the testnet, and I paste the contract ID. Okay, there it is. This is our contract ID, and you'll see the creator. This is the creator. The creator is this amount of XLM. Remember, we funded it, and we only created it just today. Now that you created a smart contract, notice that we did not store anything on the blockchain. But how do you actually store on the blockchain? And this is where in this session, I'm going to show you how to do this. We're going to create a new smart contract called increment. In the same directory. So to do that, we use the same command but with a few key differences. There's a dot and name, so we don't overwrite, and increment, so we don't overwrite the folder. So this will create another folder under the contract folder called increment. Okay, we can see by ls we have contract. Let's go to contract. You're gonna see a list. We have hello world and we have increment. So let's go back to the root folder and let's open the file. So we're closing this. So these two will come with, oh, this is the hello world. It's going to increment. Okay, so these two will come with a default program called hello world. So I'm just going to remove this, and we're going to make a few changes here. Here we're going to create a counter program where whenever you call the function, you increment a number by 1. So sticking with the skeleton of a smart contract, first thing is no std. We're not using the standard library, and here this will be importing Soroban SDK, and what we're going to be using on the Soroban. In this case, we're going to leave contract and contract implementation, which is very important, whether we, like in every smart contract that we create. And we also need to use log. We're not going to use vectors here. We're going to use log. Log will allow us to print messages for debugging purposes. And we're going to have env because it's the blockchain environment. We don't need, we're using a counter here. We're not going to use a string, so we remove this. And we're going to use symbol, which you'll see it in action. The name of the contract will be let's give it increment contract. Increment contract. And under contract implementation, we must also, it must have the same name, increment contract. All right. Now, since we're dealing with incrementation, this means that we have to create a variable. Like in normal way of programming, you create a variable, your initial value is 0, and then whenever you call a function, that value increases. But now, since we're dealing the blockchain, we are very sensitive to the data size. So we trying to be as lean as possible. So instead of using a normal variable, we want to be lighter. So we're going to be using a key value storage. So a key that would be pointing to a value. So we're not going to be storing in a variable, in a string variable, or in a int variable, but we're going to store the value that will be incremented using a key that will point to it. So to do that, we're going to do the following. We create a constant called counter, but this counter won't be an integer, it will be a symbol. It will be a symbol that will point us to our unsigned integer. So it's of type symbol, and then we're going to use symbol short, that will be our key. Now that we have that, we're now going to implement our function. We remove this, it's not hello in this case, we're gonna call it increment. What are we returning? Think about that a minute. Returning number has to increment, so we're dealing with numbers. So we're going to be returning an integer, an unsigned integer. And here's where the magic is gonna happen. So we have to return something. That's why there's red all over, because we haven't returned something. Let's mute count of type u32 equal, and this is something that you're gonna be using a lot, because when we speak about blockchain, we always writing something on the blockchain, or we retracting something from the blockchain in simple form. But when you create a smart contract, you can add other logic, but the most important thing that you should be doing is writing or retrieving. And this is why storage is important, and it's also important for you to understand all the different type of storage that Stellar blockchain has. So in this case, we're on the environment, and we go into the storage. And what type of storage? We're going to be using the instant storage. And we're now in the instant storage. We want to get something out of it. Then we use get. And if you want to set something on this instant storage, then you set it. But here we're trying to get, because we're gonna be returning a number, so we trying to get that number, the number that's gonna be incremented each time. So if it's 0, you want to get the 0. If it's 1, you want to get 1. If it's 2, so on and so forth. So we want to get the number that counter is pointing to. And by default, if there's nothing by default, it should be 0. Unwrap, or unwrap also. So if there's no number here that we can take, then it's going to assume it's a 0. So we're going to count will be 0. And here I'm getting an error message because there's no symbol. I never imported symbol, so let me go up and import symbol. I imported symbol short. Let me see if anything is missing. env as well has to be here. Yeah, env is there. Okay, symbol is there. So let's see what's going on. And here we have to fix this. So let mute count, which is a u32 equal env storage dot instance, and then we're getting a counter and it's pointing, and if it's pointing to nothing, then it's going to be equal to 0. Count is going to be equal to 0. So that is what is happening here. We can now log in the value. To do that, we do this. This will help us debug. And then we getting this from the environment. Count. And so we will be able to view the count. Okay, next we're going to increment it by 1. And once it's incremented by 1, we now have to, because there's two things happening here. We're retrieving the data and we're also writing on the data, meaning that whenever we're incrementing, we're writing on the blockchain. To do that, we now have to set something in the storage, and we use env dot storage, and the same storage that we're using, instance, and we set, and we just set it where it's going to, counter is going to point to. So counter is going to, let's use counter, and count. So we've set, and then we need to also set how long is it going to be on the ledger. So for that, env storage dot instance and extend. So this is where we're going to give it is TTL. Extend TTL, and the threshold will be 50, so it's gonna be from 50 and then 100. So whenever we call this function, it's going to do the following. It's going to get whatever the count is pointing to, then it's going to log it here. Here we're going to be logging it for debugging purpose, and then count is going to be incremented by 1, and then we're going to store whatever store it using now a new value, and then we're going to extend the TTL. So this is 50 ledger, this is 100 ledger. So whenever it's get less than 50 ledger left before it's no longer on ledgers, then you extend by 100 more ledger. So that's what it does here, and we're going to return count. So that's it. And now for test will be very simple. We just have to do a few key changes here. The same, like as I mentioned, you have the same skeleton, but now you just have to make very few changes. here we're going to be using the crate and import the incremental smart contract to use the intermediate. So let's do that. Create incremental smart contract and also the client. Incremental contract client. And you're not using vectors here, so we're just using the env here. That's the only thing you're gonna be using. And here we change our client will interact with the increment contract, so we change it accordingly. And the same, yeah, this is correct. And we also have to do that here. So now we're dealing with the right contract. Now here we now have to call our client. Our client now has to call the function. Previously in the hello world, we were just calling a function that is taking a value, that is passing a value, and then we bring, and it has to return a vector. But in this case, we just have to compare the client calling the function and then what should happen when you call the function, which is it should increment. So whenever I call it, it must be one number higher. Like I call it first to 1, call it again to 2, call it again to 3, so on and so forth. So we're going to do that here. So we don't need this. We're gonna do that. Assert equal, so we're comparing client before. Let's fix this first. Client is equal to that. Yes, we don't need this. Client dot increment one. So we expect the first call, we expect a 1. Let's copy. The second call, we'll expect a 2. And the third call, we'll expect a 3. But you see, there's an error that I'm getting here, because I forgot to remove this from the function. So we're not taking any value. We're only going to leave the environment. So let's save this, and we're going to test it. Cargo tests. And yes, our test passed. So this is basically it, and go ahead and deploy using the same way we did with the hello world, but there's going to be a few key differences when you interacting with the blockchain itself.